Hello everyone. Good morning, good afternoon, good evening. So I think most of you have attended the demo session yesterday, right? I mean the first session. So there was a demo session prior to this as well, but yesterday was the first session of the batch. So have is there anyone who has not attended? Just raise your hand if you have not attended yesterday. So I assume like everybody has joined in yesterday and are aware about whatever was discussed. Okay, thanks. We can move ahead in such a way. So I'll take first few minutes, like 5 to 10 minutes, to quickly recap what we did yesterday. So the first thing that we discussed is the operational ML systems challenges. So more than 87% or maybe close to like 85% of model never make into production. This is a study that we have seen in like from 2019 onwards, and we know that the ML deployment is difficult at its core because we are not only talking about data or code or models, but all the three. So it's a normal DevOps kind of a setup, or maybe web development or any other development kind of a thing in an app. We mostly think about code, like we version about code, and the data is mostly living in our databases system. Okay. But in the ML, so data is living in the warehouse, the live data is coming on the database, and we have multiple data pipelines as well for massaging. For those who are from the data engineering background, you will be working more on this currently, this section, and the code part is there, which we already have, like CI/CD pipelines and all the things in place. There is also a new component which is a model. So we need to have three pillars which we need to focus. Not only one, not only two, but three. So these three components, these are very important. So we need to think about how we need to work with all these three pillars in a way to synchronize the system and keep everything in a sync. Okay. So that's the major goal of an MLOps engineer here. So we saw that the experimental data science is only a few, like 5 to 10% of the entire project. So the rest of the project is all about different toolings and different processes. Say something like infrastructure, configurations, data collection, monitoring, analysis, and many more things. So this gives the view to like how we are having our current system, which is not only ML code but a lot more than ML code. This is our operational ML system. So we saw this yesterday in a paper, white paper, which is a hidden technical debt in machine learning. This is a 2015 Eurip's paper. So then we saw like what people are doing today, or maybe where teams are today. Most of the teams which we saw, like they are giving a manual handoff, like they are doing some analysis, data preparation, model training. Then they are putting the final model train in some GCS bucket or some location. Then they are giving it to the IT team or serving team. That's in that MLOps person will be there. Here it will be majority of the data scientist, labeling, data analyst. These kinds of roles will be there here. And there is a handoff. You can see this line, which is like creating like this is a manual handoff. That's what it's not connected. It's not well connected. That is the reason for most of the people, though those who are not having their production models in production, like companies are suffering to get the model in production. They are chasing it, but there are some process issues which we will look at. Okay, so this is the description of the current work that you saw, like where people are today, and it's a high degree of manual work, no reusable or reproducible components, poor handoff between data scientist and the MLOps, and then models don't make it to production. So this is are all the like like the possible issues because of this, and there is a lost effort and no return on investment. Why there is no return on investment? Because if the model is not making into production, we'll not get the investment return. Like so that because it is not predicting and creating business for us, it is has no effect. So all that we got to understand that the process that the current organizations are following doesn't scale. Like there will be few organizations which will be matured and we'll see. And next time you see any organizations, you would like to see more details, like on which level they are operating. Is it they are having MLOps level 0, level 1, level 2? We will see all that. So that's what we got to understand, that if you need to have a large number of models, you need to automate. So what do teams need? What we understood, like they need an automation of an ML process. So reduce time to deployment. Like say example, whenever a data scientist has given new model a code, or maybe there is a data we need to deploy, there should be some kind of automation which can be reducing the time instead of manual. So deployment frequency, like say example, we are doing a deployment once or twice a month, it can be reduced. So we can do a deployment within a 5-day, 10-day period, or maybe 2 weeks. So that is the kind of way to operate. So these are all the, the current team needs. If you see, I'll give you a 30 seconds to read like what current needs are for the teams. And this is the, again, I have talked to multiple teams, those who are suffering these issues, and this is all their needs, okay, I think pretty much we are on to track, like where we left tomorrow yesterday. And then we are just describing what is MLOps. It's an standardized process and capabilities for building and deploying operation ML system. Like basically, it's nothing but a set of processes, maybe a set of like a process and a way of building and deploying models. So MLOps framework, we saw that there are three kind of things. That is a data engineering, ML engineering, and web app, like web or app engineering. So ML is in the center, which is like the user for ML is the web and app, and through that it is shown to the other users. And the left side is the data engineering, because ML is the one who is consuming the data engineering. Okay. So we'll look at the MLOps maturity. I think we saw that yesterday as well, but we'll again look at it today to recap it. So as I mentioned, the level 0 or manual process, where we build and deploy manually. We don't have any automation. The data scientists do the things in notebook. Then the IT team or the MLOps team, they come in and they take the models, they produce the artifacts, they deploy it manually. So every time, say example, there are hundreds of models. So we'll do hundreds of times. So repeat is, so the process is repeated, and there is a like high amount of lead time. Say example, in my case, I've seen it takes almost like not only a week or two, but it takes 4 weeks, 4 to 5 weeks to deploy a single model if you're doing this process manually. So imagine like if you have so many of different models, because today industry doesn't have one or two models. So every organization, say example, if you consider Uber, right? So Uber is a taxi service. If you consider any taxi service, they have a lot of different use cases, such as they'll predict the demand. They'll predict the time of the day, like how much the demand will be. They'll predict the price, how much the fare should be for this particular ride. Then they'll see like weather conditions. They'll see other things, and by that all this consider a single model. So there can be n number of models. If you are considering Google, they have tons of models. Like they have thousands of models in production. So these kinds of number of models is like which we cannot do manually. Like if you are in the manual process, your models will be pretty old. They would be not like giving us the best of the predictions. You wouldn't be able to compare and validate the models. So all these are the challenges of the level 0 MLOps process. Okay. So here is where the most organizations are. Okay. You guys are with me on this? You got a recap what we discussed yesterday, and good to go ahead. Okay, thanks Pradeep, thanks Vikrant. I think for confirmation, let me quickly jump onto these things. So we are progressing towards level 1. So what do we mean by level 1? So level 1 is nothing but you automate the training process. So as we saw a diagram yesterday, we'll again see the architecture. And on the request of yesterday, I have got the architecture diagram with the services, so that you can imagine, when I am talking about CI/CD, what I am talking about, which tools we can use, and what things we can do. So with all that things, we can move forward today. So, and the final, the highest level of automation that we have seen yesterday was level two. So we could not see and delve deeper into that, but we today, look at it in a very detail. That's nothing but automating the training, validation, and deployment. Say, what do we mean by, validation? It's like one model you have created, but you will not directly push that model into production. You will validate if the model is fair enough, if the model is good enough with the previously deployed model. If you have no deployed model in the production, then you will validate with the data and every other things. So then only you will push the things into production. Without that, we will not be doing that. So that's all the process building things which we have to do. And the beauty of these things is, like, if you create a framework once, or if you understand the things once, you can do it like n number of time. You can replicate it for n number of clients. You can replicate it on n number of different projects. So if you understand the system well, this will be there with you for a lifetime, and you will be building on top of this. So which will enhance your work, as a ML engineer, as a data scientist, as a data engineer. All these qualities will help you in all. So this is the beauty of it. So this is the MLOps zero manual process, which we have. We won't invest much time on it because we have seen this yesterday. So I just want to recap, like, we have seen the ML team here, the ops team here, and we need to integrate this team. So that's why we have MLOps. Like, the integration between these two teams is like, whatever being developed, we need to quickly push into the production without much manual intervention. So what are the characteristics of manual zero, or the level zero manual process? The script and notebook driven, like, they are not in a process driven. They are having fewer releases. Like, if your organizations is like, I have only one or two model, I need to train in a 6 months period of time. Like, it's not, the data is not that changing, the performance is not that changing. Then this is a good model for you. Okay, there is no continuous deployment. There is no performance monitoring. So challenges, what can be the challenges? Okay, the human error can be there because it's a human process. So without automation, humans can make some errors. Models can break because the data ever evolves. Like, there is, the data changes. The example, I gave an example of COVID yesterday. So COVID hit, and the data patterns change. So buying patterns, people how they used to, the traveling patterns change. Everything change. The living in the houses, like, the patterns change. Now we want extra room in our house for working from home. So these are all the examples of how the data evolves. Like this, evolution in data happens in all different frames. So example, take it any other examples as well. So these are all the, like, different processes, like no active monitoring, no retraining cycle, or not having an consolidated ML technology. So this is the lowest level of like MLOps, or maybe like there is no MLOps here, like, or very little, like, the way we are doing it's all manual. So the ops person is doing all the manual work here. So this is where most of the organizations today lie, and not only like a small companies, but pretty much big companies are also doing the same things. Okay, and if you understand what is the reason behind that, because the teams don't have that equipped knowledge. That's why people are going to acquire this knowledge. Perfect. I think we are having the stage to start for the level 1 and level 2 automation things. So level 1 automation is nothing but having like the series of steps. Like, we have the continuous integration, we have a continuous deployment, we have performance monitoring, everything. So highlighted sections are the ones which are added by level 1 automation. So if you see, like, we are building a pipeline now. So basically, what a pipeline is, it's a nothing but whatever steps the data scientists do on their notebook, we are we are adding it into a series of components. So as I shown you yesterday, a pipeline, which is nothing but download the data, prepare the data, train it, evaluate, validate. So that's all. And once it is finally done, we'll put it into the model registry. And then once you have the model registry, so the train model will be deployed into the prediction service via a system that is a CD. So usually, if you have any experience, so you must know, like, GitHub Actions. So there is a cloud build, or maybe, like, any other service which is very similar. So GitLab is also having every other open source, or maybe like cloud provider has this service. Okay, so we'll talk about this in a greater detail later. So once we have the prediction service, we are looking at the performance monitoring because we want to see how the system is performing, if it is well enough, if it is having the required performance, and then if the performance is not up to the mark, or maybe there are some issues that are detected by this performance monitoring thing, so we'll trigger it. So it will trigger an automated pipeline again, maybe for a retraining purpose, or maybe, like, there is a issue, then this will trigger the performance monitoring will trigger to a data analysis thing. So they'll analyze, okay, the accuracy or maybe the other metrics have gone substantially low, which is, like, very alarming. So we need to do something about it. So that's why we have a manual process here. So this is a, again, a semi-automated process which I call, and it's much to the mark, and most of the organizations want to get here. You know, like, they would want to include all of these pieces. So I missed feature store here. Sorry about that. So feature store is nothing but an one like a collection of our features. So say machine learning models need some features. Like, say example, if you want to predict a taxi fare, so you would need many features, like what time of the day it is, like what location it is, where the trip is starting, where the trip is ending. So something like these features which you need, like what is the weather condition, how long is the traffic taking on that route. So all these things will be nothing but you will be capturing it into the feature store. So feature store allows an organization to share all these features together. Like, different teams of different teams of different verticals can get the same kind of features if they are solving similar problems. So this is what feature store is, and feature store has multiple functionalities such as batch and online, like both. So we'll look into the details of feature store later. Okay.
But wait,
Right.
question here, Mahesh. Like, like if you in this diagram and the first step you are saying that pipeline deployment, right? So, model registry is came into the picture after that. So, what happening? Model registry means, like, just try to understand what's going on. It like you're configuring database or something, maintaining some configuration details in the model registry, or what's going on in that area.
Correct. Yes, Mahesh, you are exactly right. So it's not a database, first of all, but we are maintaining all the configurations and the metadata. Okay, let me go back. So is it okay that I switch to, like, demo also, like, and or you want to cover the theoretical part first, and I'll answer the questions later, like how you want to take, because we
Anything
are
is fine, Mahesh. Yeah, anything is fine. It's up to you. Yeah, please. Yeah,
okay.
anything.
Cool, cool. So just give me 5 or 10 more minutes. I'll cover the few things here, and then we'll quickly go on to the GCP console to see the model registry, and we'll look in a detail, like, what do we store in that. That's a very good question. Appreciate it. Okay. So we are on to level 1 automation. So let me just cover, what is level 2 automation. So basically, level 2 automation is nothing but we are now adding the CI, like, once we are already having a only here we were having certain pipelines. Okay, we were creating the pipeline deployment from a source code. But here we will not only like create a pipeline, but it will like do the building, testing of all the packages and the pipeline components individually. Like there will be a unit test, there will be an integration test, and there will be, the the orchestrated experiments is again having all of this testing as well. So the data scientist will do the testing, and there will be a CI process which will do all of this. So this is the greatest level of automation which you can have. Like everything is well tested into this. Then you have all the things packaged into a particular system. Then you are deploying in the system, which is very similar. And it's again, an automated pipeline that you have, and all the metadata stores in the ML metadata store. So once everything is there, so from here, I think the things remain same. So only changes in the top section, like we are adding, the build, test, and package components. So why we are doing this is because of the reusability. So we are having an, better reusability once we build, test, and package the components. So we'll see like what are these components, how we build it, how we test it. We'll see all of this. Okay. So what are the characteristics of level 2 automation? So there is a no cutoff in ML Dev and Ops. So ML Dev and Ops are working as a single team. Okay, they are like working in a different, like there will be few persons in ML Dev, say few person in ML Ops. So that there will be certain guidelines which you have to follow. CI/CD will be intact for models and ML pipelines. Continuous trainings are there. Automated triggers is there. Live monitoring of the ML metrics. Here is the monitoring metrics. So, but the requirement is you need the engineering skills, requires framework confidence. So which framework we are talking about, such as Kubeflow, MLflow, these framework requires the flexibility and agility. Reason being, you need to change and think about the components. So this is all the requirements and challenges. Now we'll pause here and answers the Mahesh question, and then we'll go ahead with the ML lifecycle, and different processes. I think yes, we were here. So whenever you are going on your console, you just need to search Vertex AI if you are on Google. So I would recommend everyone of you like to create a free trial account and do some demos with me, because I'll be giving you assignments. And if you are comfortable with Azure or AWS, we'll be quickly showing you that as well in a maybe few sessions of time. So we'll be having our setup ready for the AWS and Azure, and then we'll see there also. But as a learning experience, I would recommend you to create a free trial account with GCP for the few sessions. Like maybe get your hands dirty on this and just create how the way we are showing you the demo, and we'll give you some time also, some questions. So this will be a good opportunity for you to learn and to experiment yourself, okay, in the first hand experience. So how many of you would like to do the demos and then come back with this? So are you guys interested, or you're just interested in looking at the class? Okay, so it seems not many people are interested. Okay, cool. This is the model registry. So I think we were looking this in our one of the demo sessions, I guess. Yeah, so this is the tool that we were talking about so far, Vertex AI. So Vertex AI is nothing but an unified ML platform, which is having all the required things in a single umbrella of the product, and which we are having, the dashboard. Model Garden is having all the different models in the LLM, their own Gemini model, or maybe any Palm or any other model, for that matter. So they have like Cloud A, that's a different model from different organization. They have YOLO, they have diffusion, stable diffusion models. They have Llama, every other model you can use from here. Then we have ML pipelines, the one which we saw yesterday. This is just a test pipeline which I have run, like a tabular data pipeline. So this is a Kubeflow pipeline on the backend, and this is having a different number of steps, like download data, pre-process, train the model, okay, then you evaluate, and then finally deploy the model. So all these steps which we saw, this is here, and we are getting a KPI metric. So what is the MAE, MAP, MAC, or MSC? What all these are? You don't need to worry. Like we'll cover these things in a rough manner so that you know like what is the background of this. So I'm just giving you a high level overview of this tool right now. We have a workbench. That's a notebooks. This is where most of the people work, or you can work from your local machine as well in your VS Code setup or something. So if you see like the notebook, this is like a machine which is available and installed all the things. So if I just click start, it will start the machine. It will take like a minute or two to start it, and you will be available with a Jupyter Lab link here, which you will have to click, and then the notebook will start. So as a first step, once you have the free trial, right, you got a GCP account, you will get a $300 of credit, and then you will have create new instance. Create new instance, then you can, use any of the name here. Then you want to choose whichever environment you want. So for the, you can leave it default, and other things also you can, either leave it default, or maybe like if you want to change, you can go into the advanced options. So advanced options will give you all the options different available. Okay, such as machine type, you can change. You can change the idle shutdown. Like, if I want to shut down in a certain period of time with inactivity. So all these things can be, changed, and they can be created. So we'll look at the demo. Once we have a demo, I'll help you how to create this. This is a Vertex AI Studio. As I told you, there are multiple models. If you want to play with them, you will go here. So for data sets, as I mentioned, there is a tool feature store, which is having we'll look this into a detail. The data sets, this is are the inbuilt data sets. Whenever you do an ML like problem solving, you will want to have data sets. So these are the managed data sets. Nothing but like Vertex AI has some like features for this. So like you can classify which type of problem you are solving. It's a tabular, text, video, whatever. So these are all the kinds of available metadata. So in the demo sessions, we'll go line by line. First create a workbench, then create a data set, training experiments, all the things. And the question where we came here, model registry. So here is the model registry. It allows you to give us, say example, there are two things. One is create. So create means there is an new model that you want to create. So if it is having a managed dataset, you say managed dataset. Otherwise, it's a no managed dataset. It is having any labeling set, so it's a custom. What objective? If you have custom training, you do this, and similar things like you continue having. If you say like my custom training or AutoML, so there are two types of things. Okay, in GCP, like if you have automatic machine learning, like you want to just give data to ML, and they you would like to have a model, and it's the responsibility of the AutoML to give you all the different options and what is the best. But the problem is for AutoML you need to have managed datasets. So for that we will definitely look it into this to create an uh, like an entire pipeline which will create a data set, which will create an AutoML experiment, and it will train the model. Okay. So this you can also do along with this because you don't need any experience of ML prior to this. You just need a little bit of Python knowledge. You just need what dataset you are using, which data you are interested in, and you don't even like bother about the ML algorithms. Okay, so we'll look at this in a demo part. And there's a separate thing which is known as import. Like, say, example, you have trained a model on your own machine, or maybe some different physical server on your organization. So you now import a new model. So import a new model, say, like, taxi fare prediction. Okay, this is our new model which we are importing, and then we'll go look at the advanced. If you have any other existing model ID that you want to keep, you can give that. So now here comes the metadata. Once you have the model, okay, is it like you are importing a artifact into a new pre-built container? So there are some pre-built containers. They are TensorFlow, Scikit-learn, XGBoost. These are all the different frameworks that are available in machine learning. So there is a limited supported runtimes which we can see on this link. If you would like to open and see this, so until it is loading, we'll go here. So Google has given us a pre-built containers, so we can use that. Otherwise, if you have your own requirements, which most of the organizations have, we'll import an existing custom container. So as a like ops engineer, you will have to help your data scientist team to create a new custom container. And we'll also look at this example. So the custom Docker container must be stored in a custom container registry or the artifact registry. Okay. And then this container image is there. We'll have to find in the container registry or artifact registry. And then once we have, if there is any entry point that you would want to keep here, you will have to keep here the model location. Someone has something to say? Hello. Think I heard some voice. Anyone wants to say something? Think Manikya, you are on, like you are speaking. Okay.
Sorry, it was by mistake.
No worries, no worries. Yeah, it's fine. It's okay. So we have a model artifact location, which will keep the model into GCS and load the model into here. Okay. So we have some arguments, environment variables, prediction routes. These are all like advanced things. We'll definitely cover this. I was just trying to answer, what metadata we are using here, or maybe how we are capturing here. Once you have all the things listed, you will be seeing here. So like I'll open one model here. So this you see version detail. I have mentioned the container image. Like this is a pre-built container. This is given by GCP. Like I'm not using my own container because it's a very simple model. It's a scikit-learn model, and we are using scikit-learn 1.2 version. And this is the bucket location. If I put it here, we'll see like, so you see model pickle. This is a 70 MB file, and we are having all the ML model packaged into this. You know, so this is how you work, and these are the list of pre-built. So CPU, GPU, whatever you need, TensorFlow framework, whatever framework you need, you can see it from here. There are list of supported runtime only. You will have to see and work through. And you can also do batch predictions, deploy into an endpoint. What do we mean by endpoint? Endpoint is nothing but, place where like your like business team or maybe any other downstream applications can hit on this endpoint. So this is nothing but it works in a REST API format. You have a API, which is, you have to send a JSON request and you will get a response. So we'll definitely see this in the demo session, like a later one, and we'll all look at this. So now once we have all the, base things ready, so we'll quickly jump onto the demo things. Okay. And, it looks interesting or like, how's your feedback so far? Like, so enough of theory, like, right? Or maybe like you would want to know a little bit anything more.
No, it's fine.
So this is the ML life cycle. Like, what we were so far talking. Now we have the picture of what a ML life cycle consists of and what we need. So the MLOps work is to tie all of these pieces into a pipeline kind of a thing, or maybe like set it into automation. So the first thing is ML development. So where the example I told you, right? In a notebook, a data scientist will write a code for a ML model, and then it will be saving the model into GCS bucket or maybe any other bucket for that matter. And then we'll use the training operationalizing, like create a pipeline. This is as a ops dev, you are using this. Then you will create a continuous training process. You'll create a continuous deployment process. You will have a prediction serving, which will be having a continuous monitoring in place. And the continuous monitoring will again, either do the training operationalizing or maybe like involve the ML development again if there is a need. So this is not always done, but yeah, in a certain aspect we do that. So this is how the cycle works. And to the center of this, we'll have a data and model management. Okay. So to look in a different lens, this is a like inflated, this is a closed image. This is an inflated image. So this is like ML development. You have a code and config, like you put the model like in the code, and you have a code to produce a model. You put it into the training pipeline or maybe operationalizing. Then you have the training pipeline into a continuous training, like if there is any requirement of it, so that you can execute it again. For that matter, I'll just jump on to the again, like, so this was my training pipeline, right, which I show you. This one, I think pipelines here above. Yeah. So in this pipeline, now I have all the code written here. If I want to write a thing, right, you just have to press this clone button and it will clone this pipeline run. And for that matter, okay, yeah, I want a recurring pipeline, I want a frequency. This is all I am doing through the console, but you have a test, and then this is a run name, one of a pipeline, or maybe like advanced. If you say recurring, it will ask you all of the details. But right now we have one of, and then you will submit it. Then there is output directory. This is again, it is having some output directory. And there are some parameters which you want to put, like a deployment threshold and all that things. So you know how easy this is. Like once you have a pipeline, you just need to do all of these configurations and just submit, and it will create a new run out of it. So you can see like how easy it is once you have everything in a pipeline setup. This is using the UI, but I can do this using a code as well. So imagine you want a scheduling system, or maybe you have an automatic trigger. Now you see like how this is just triggering in a 17-second of duration. It warmed up the container, and it is giving us a new all the things. It will show you all the logs here, and it is running like fresh, downloading the data, provisioning new machines, and all this is running on top of Kubernetes. So, and we don't have to do anything. We don't have to manage anything. We just have to write this code once and then orchestrate it. Nothing much. Okay. So while this is running, we'll again look at the thing, and I just wanted to show you like how simple that is. Like once you have this code written up, and I think we had our Jupyter notebook also. So let's see, like, and we can show you, I can show you like how the Jupyter notebooks looks like, and what all things we have written. So all this pipeline has been written in this Jupyter notebook. So this is our new pipeline. This was our old pipeline. This is our workbench. This is our Jupyter lab. Okay. So this is how a Jupyter notebook looks like. This is a very typical environment that you have, and there are certain bunch of notebooks for you. If you create, you will have this two, SRC and tutorials. So the source folder and tutorials will be the only two folders for you. Rest of the folders I have created for the demo. Okay, and then there are some notebooks like a level 0 level. I wanted to show you how the level 0 automation looks like, then how a level 0 working is there. Then there is a KFV. This was like, no, I was trying few things here. So we'll definitely look in all this, demo things, and we'll have something like this created by our own. Once you have understood the code, you will have to work on this and create your own pipeline. So trust me, within a few sessions, I think 2 or 3 sessions maximum, you will be having your own pipeline like this, and you can customize it with your own data set, with your own things. So this got completed. And as you see, like there is a downloaded data set. Like, this component task was to download the data from internet, package it into a data set, like a system data set of Kubeflow, and put it into a bucket. That was the job of this particular pipeline. And now here we have a component. This component is pre-processing the data. All these are running on a Python 3.9 base image, on top of which we are installing few packages. And then here is the model training. Okay. Here is the evaluate model. Like once we have the model trained, you are evaluating on the test data. Okay. And once you have the evaluation model done, you will store the KPI. If the model is good enough with your performance requirements, you will deploy the model. Register it into a Vertex AI registry and then deploy the model. So this is how the pipeline will look like. This is a very simple pipeline. So this is a very simple to start with and to learn with. Okay. So you can see like how every component gives you own like particular, and it's running on a separate machine. So this component ran on a separate machine. This component ran on a separate machine. I can even parallelly run these things. If I don't want, these things to run in a sequence, I can run parallelly because our work is dependent. Like, pre-processing of data is required on the downloading of data. Like, the first step is to download, then only we can pre-process. That's why we have done. So if you see, like when I press view job, so it will spin up a new page with all the, trainings here. And this is running on Python 3.9 with all these things. You know, this is running. The execution type is Google managed. We are not managing the machine type with this one. So that's the beauty of it. Like, all this is separated by a different, like, it might run on a different machine. It will spin up the container for us on our, thing. Now we have splitted the data. So we have splitted the data into train, validation, and test data set. So if you might be aware, in the ML system, we split the data, like, you split the data into. So this is a, like, how many we can check, we are splitting on 80, 10, 10, like, there is a 10% of validation, there is a 10% of the test, there is a 80% of the training. So these, like, by these parameters, I am specifying. Okay. And these are the resultant data sets. Now my model is training. This can take a little while, but yeah, the job has started running. You can see that how flawlessly it is running. It is spinning up new machines for us, or maybe, like, reusing the same machine with a new container. Then it's using our base container with all the required packages. So for this job, I'll again click on view job. And if you see, like, whatever metrics we want the artifacts we are passing, the system data set, the location is getting passed, and the function which we want to run. That's a train model. Okay. Hopefully this is looking interesting to you and you have all the required, attention here. So this will now we'll stop this pipeline because I don't want it to evaluate and deploy the model because it will cost some money, and I can, if we can see that, but no, that's not a problem. If you want to see, like, there is already some deployments done. If you see model registry, then we have registered the model, so many things here. And there's the online prediction. We have created some, endpoints here. So what this will do is this will create a new endpoints. So in the pipelines, if you see, this one is running. Now this will create a new endpoint. Now it's on the evaluate. So in a matter of few minutes, it will evaluate the model and then it will put to the production. So let's go on to our thing, and then again we'll come back and see like what model it has registered, how it has deployed. Let it happen. Like it will take a 10 to 15 minutes more, I guess, for doing all these steps. So deployment is the most time consuming process because you package it into, you procure a new machine, you procure a VM with the required capacity, and then you do a auto scaling mechanism enabling. Okay, so all this requires some time. Now you understand, right, why I meant continuous training? Because on the click of a button or maybe on a single command, you can do the training. Like how much time literally it took us? It took us only a few couple of seconds, and we just ran the configuration with a similar, or maybe I can change anything. Okay, so that's how. And we at the end of that, we got a registered model, like, and that is also deployed. Like within next 10 minutes, my model will be deployed onto our endpoint, which will be ready for the prediction, and we can just hit the endpoint and get the prediction. Okay, so that's as simple as that. So whatever things that I've walked to you, I show you in the demo. Now, the thing is, I want to show you how I build this so that you also can build this on your own. Okay, that's the major learning part here. And we have the prediction serving, like we serve this all predictions on the endpoint, and we collect all the logs. So as you see, I can show you all the logs also, how we are collecting, what all logs we are collecting, and we are doing continuous monitoring from here. So this we have to set up. We have not set up right now. I'll show you how to set up this as well. So yeah, now we are converging to find out what are the core MLOps technical capabilities. What all MLOps processes required. So we need experimentation from, let's go from left to right now. Experimentation, data pre-processing, model training, model evaluation, model serving, online experimentation. What does that mean is, once you have the model serving, there should be a way to trigger, maybe like we saw here. From continuous monitoring, there should be a trigger here in the model management, and there should be a trigger here to a continuous training, or maybe like the ML development. So this is nothing but which we call a online experimentation. So we have a model monitoring, ML pipelines, and model registry. Like all these steps, I think you already know. I just, this is in a separate format. It's just that for understanding, there are different ways of showing it. Well, this is the best diagram, I think, because this covers everything. So this is what I was talking about yesterday, and someone was asking that we need to look at a different amount of tools, or what you are using, like when you call CI/CD, when you call like notebooks. So here is with, so this is again a GCP based thing, but we can similarly replicate this with Azure and AWS. I can show you the same diagram creating with the Azure or maybe it's like AWS. But as we are discussing GCP and we have started with it, we will see the GCP. And similarly, you can, if you have worked on Azure or AWS, you can imagine the similar services if you know that. If you don't know, you don't need to worry. We'll cover from the scratch there. So the first service is the notebooks, which we saw. All things, the experimentation development work start with the notebook. And in Google, for storing the repositories, we have a CSR. So in the open source terminology, we call this GitHub, right? So we have GitHub as an open source tool. And for CI/CD, we have cloud built in Google. For the open source terminology, we have GitHub Actions. Okay, so which does the CI/CD work for us? They have their runners, so you can replace these blocks with GitHub and GitHub Actions accordingly. Then you have uh, pipeline components in a container registry. In open source term, we have a Docker Hub, which does the work. But since we are on Google, we are keeping it into the container registry. Keeping all the pipeline artifacts, the base images, everything it into the container registry. And also, there will be some JSON files which you will be putting onto the GCS or something. So that is not listed here, but again, like you will be doing that. And the as a thing, there will be some data sets which we saw, vertex data sets. So there will be some pipelines, which is the vertex training pipelines under the hood. These are Kubeflow, and this can be also scheduled, as I mentioned. Like once these are retrained and these are running on a schedule. So all this is a resultant, and we will have the model in our model registry, which is again kicked by our CI/CD process or cloud build. In the open source, we have sorry, GitHub Actions, which will push this on our serving infrastructure by checking, whether the quality of the things is there or not. And then again, we have a vertex model monitoring. Also, you have a cloud operation suite, which will help you to alert and trigger. So underlying vertex model monitoring will use that service. Okay. And then we have a human in loop and again the circle. So hope it is making a little bit of sense now. No, I know that this is quite new for you, and this might be like quite daunting, or maybe seeing a lot of components here and there. And that's why I'm again and again switching back to the console to make you comfortable on this. So now our register model has been registered, and now it's going towards deployment. So let's see like which model it is. Model resource name. We'll click on this one. We should see a new model which is registered just now. So if you see, like right now we are having a new model register version, and it has created 831, which is just 2 minutes back. And we can see that this model is ready. The status is ready. We'll click on this one version and see like what. So if you see like this we are in the online predictions. In the model registry from, we have version details, as we can see. There is a container image, there is artifact location. So this is the same SQL and CPU. We can do batch prediction, deploy and test on an online prediction. If you see, still the deployment process is happening. The last updated on 832. So from my knowledge, it will take more like 10 minutes. So this has only took like 3 minutes 54 seconds. Usually it takes 10 to 15 minutes to run this component. Okay. So we can maybe cover something, and then we can see like how this has been deployed to endpoint. Okay. Think any questions so far? Like,
Yeah, Bhavesh, the one which you show in the previous diagram, the number of components, the visualization of the workflow,
Mhm.
not that one, the one which you have shown, the components workflow, the
Yes,
where
yes.
you make the model. Yeah, this one. So this one, the CA pipeline will be there behind the code will be written, right? The CI pipeline which you are showing it, how we
Yes,
can
yes,
write
yes.
it
Yeah, yeah.
code.
This is the code. I can show you 1 second. So this is the
Okay.
code behind it. So this is a build pipeline, Python script, and
Are we creating a code and then we are seeing that those components, or we are building directly through the components which you are creating, and then behind it will write the code. So how is it?
no.
We have to write the code, and then
So the best way, like the best way is to create a code. There are some tools which allow you to do the drag and drop as well. Like I think Azure has had that service a few years back. I'm not sure they have discontinued, but they had both, like the drag and drop and the particular code. So they will even Databricks. I am sure like they are not having any drag and drop thing. So most of the cloud providers, they allow us to write the code, and only a few cloud providers allow us to drag and drop, but they have very limited functionality with the drag and drop. But with the code, you get a entire like control. What base image to use, what packages to install, what are the internal functions. So it's a very simple code. It's nothing like complex. If you see here, like the download data is having an input data, that's a string, and we have an input file name. Then we have a downloaded data output into a data set, and these are all the like packages that we are installing. Like there will be 4 packages, and the base image is like this. So I'll explain all this code to you, so you don't need to worry. So every component has a code, like download data, preprocess that data, and then train a model. So every component has their own particular code, and if you see, it's hardly a few lines of code. So every component is hardly like a 5 to 10 line of code. So don't worry about this. Like we'll look at this in a great detail. Okay,
No.
and you will be very comfortable with the code. And this code can be run on, like exact same code can be run on Azure. Exact same code can be run on AWS. Do you know why that reason is? Because we are using open source package. So open source package means you can run. So this is our open source package. That's a KFP, Kubeflow. So if you have a Kubernetes instance on the cloud, you will have to use the same package, KFP, and this can help us to run on any different cloud. Even for that matter, on your local machine, if you have a Kubernetes like installed and everything is set up as required, you can run this on our local as well. So that's also one of the possibility.
Okay.
Yes.
So, yeah. Then at the back end, there are some worker nodes, or the notebook means it's the worker nodes it's creating, or instances it will be creating, right? When we deploy to the Kubernetes.
Yeah. So there are some worker nodes. That's what I told. Like this, if you see view job, right? This
Mhm.
particular view job is having required E2 standard 4 machine. This is procuring a new machine. If you see worker pool 0, this is a
Mhm.
chief node, and there is a container location is also here. If you say like I want this particular step on a 4 machine, I want to divide it, it will run this same step on a 4 machine. Now for the, because I have said the number of machine is 1, no machine
Okay.
count. So here we are putting all these things. So while configuring here, I'm putting all of these things.
Okay.
While submitting the pipeline, I'll do all of the things. But the beauty of Vertex AI is that we don't need any managed, like, we don't need to manage anything. Like they'll manage it, we just need to command it. Okay. But in the other cloud providers, they ask us to manage it. Like, you know, so we might have to see some options where they are giving any managed service. We will opt for that. Okay.
Okay.
And
Hmm.
we can also see like how we need to. So there was a service in Google as well where they gave us, you know, like to manage the entire Kubernetes pods as well. So I can show you that as well. Let me show it to you. This is our pipeline. This was known as AI platform. I think they have discontinued that particular product. So this was happened like back in 2021. So if you see like go to AI platform, it will come to the same. I think no. Yeah. So if you say Vertex AI is our next generation AI platform, the migrate your resources. So this was the older version. If you see you have Workbench, you have pipeline. No? In the pipeline, you will have to create a new instance. If you go to a new instance, it will create an entire, see Kubeflow pipelines. If you click on configure, this took almost 1 hour, to install. Okay, there are some permissions that is not there. I think I have to create containers, so that's why this is a highly, you know, so it's a very heavy range product, and we need to create a Kubernetes instance for this. So yeah, GKE, the at the background they are using GKE. Okay, so
Yeah. Yeah.
if required, we can look at this service as well. Like if someone of you want to utilize this or are utilizing this in your organization, similar things we will look onto the Azure and AWS as well. Like how we set up similar things. So we are getting our like work ready on that. So we'll
Mhm.
work on the demo sessions on Azure and AWS as well. Okay.
Okay. Yeah. So, so you are here. You are deploying any applications, or how we get it? Like some, for example, there is a small application which the forecasting or something you are doing. So the code will be there. The code, source
Hmm.
code will be there. The code will be deployed, right? The code, and also we can see what the application is through the browser once it is got deployed into the the Kubeflow or GKE.
Yes. So we are not deploying the front end. So
Mm-hmm.
you can only, like you are deploying a back end, like a API. Okay.
So,
This is a REST API. So if you see online prediction,
mm-hmm.
here our deployment is happening now. Okay.
Okay.
If you see like it's deploying. So you will, once you have that, you will see a sample request format. So this you will have to use. So either you want to use a REST API or maybe in a Python format. So Python, it is giving you a function. In a REST API, it's giving you a curl command. Okay. It's giving you certain instruction, then you have to pass the data in certain one. So now our model is ready. Okay.
The whole the API or the REST API, that is you are converting again into an image, right? The one you are showing earlier inside the code. You are pushing to even to the using. Are you using the container registry also to create an image and
Yes.
pushing it before
Yes.
going
Yes.
to the Kubernetes? Everything is containerization, right?
Yeah.
This
Everything is.
is.
But if you see here,
Mm-hmm.
every step is a container. This is a
Okay.
container. This is a separate container. Okay. This is a separate container. And we are using Python 3.9 as a base image. And we are writing.
Oh.
So again, we are not writing manually code for containerizing each and everything. There is
Mm-hmm.
so we are using this @ component decorator. This is doing everything for us. Okay.
Oh. Okay.
So these are some high level, uh, what do we say, high level packages that these guys have created to ease our life. Okay.
Okay. Yeah. Yeah.
Yeah. So earlier we had to write all of these things if you had to, do it on the manual thing. But yeah, now they have. So now you just have to put the instance here. No? You have to put the instance here, and then it will give you the output.
Okay.
If you want to see it live, right? So these are the instances, right? If you put it in a certain way, it will give you the output. But we need a format, right? So now
Mm-hmm.
here we have a format like a sample key, sample value. Say example, you have instances, then you have a list of instances, and then you want a key value pair. Okay. So now we want to have a key value pair. Say example, key value means your this is a one, okay, 1 0 and whatever. But what this one is belongs to, there is a way we can. So the one is the instant. That is a DT, date time, season, year, month. So the corresponding column you have to write. Like, season equal to 1, year equal to 0, month equal to 1, R equal to 0. So if you put this in a certain format, this particular JSON request will be pushed, and it will be giving a response to you. Okay. So this will
Oh.
predict the count column. Like this is a, hourly count of a bike. So on some station, some specific bike station, it's a counting how many bike were the trips were made on that particular station at that particular hour. So we are predicting that. So if you give all of this in input, you will get this as output from the model. Okay.
Mm-hmm. Yeah.
This is a simple like a bike prediction
Okay.
problem. Yes.
Okay.
So if you put this in a certain format, you will get this here. So we'll see in the next session. I'll keep this thing ready, and then we'll
Yeah.
use the same particular thing. Okay.
Okay.
So I
Okay. Great.
yeah,
Great. Thank you.
yeah. Hope you were able to align with the session. And so in the next session, we'll look at the pipeline code from the scratch, and we'll build this together. So I would like to see your GCP accounts ready in the next session, and then let's do the hands-on demo as well. Uh, Along with you, if you want to code along, you can use. I can paste the notebook link with you, and you can run along with me. Okay. or maybe like I'll run along the steps and then you can again try it on your own as well. Okay. I think
Okay,
we can
great.
go through the code and we'll also look at the manual steps. Okay. So we'll first look at the level 0 or the manual handoff, how that happens. And then in the same session, so this can take maybe 2 sessions, but we'll go this in a deeper level. Okay.